Okay, we don't have much time, so just going to be going over these quickly, and we will cover as much as we can. This is not really a tutorial. This is a hands-on practice such that you get comfortable exploring yourself. If you go, first of all, if you go to my website, at the bottom of it, the link, if you click on the YouTube link, it sends you to a YouTube channel that I have. And if you look for the videos which are here, if you click on videos, it will show you all the videos that are there. If you go all the way down somewhere in there, you will see two specific Maple tutorial. But these are on an older Maple, not on Maple 18. But all these commands also work in here too. So if you want to watch them, you're welcome to do that. But Maple 18 is also a much productive version than it is. This is one of those tutorials. And so this is one of those tutorials. You go there and play it. It will show you different steps. This I did in 2013, so it's a long time ago. And some of this stuff are really very old. The new Maple does a lot more these basic steps. So that's one of them that you can find. There is also there are two of them in there. There is also, you can also go to YouTube, to Google, and just type YouTube Maple 18 tutorial, and it will show you a bunch of them in here that you can explore for yourself. So it is a very useful tool that widely used throughout education, industry, and research. So, and one of my hopes was that you guys in your calculus classes, differential equation, all those classes that you are taking in the math department are very fluent with this. But I have asked the students that almost nobody has been exposed to this. So I said, well, look, on my desktop it's like a maple leaf and a number 18 in there. When you click on launch this, let's do this from the start. It launches Maple 18. It usually comes up with this starting version, which says what is that you want to do. And as you see, there are a lot of stuff that you can do in almost anything, from optimization in your operations research that you can use, nonlinear, linear programming, all sorts of stuff, or your linear algebra, calculus. Basically, anything that you want to do, you can do in here. Differential equations, all sorts of stuff are here. You can start either a new document, which I show you what the difference is, or a new worksheet. Or you can click on getting it started, and it takes you to the tutorial that you can follow up. In fact, the tutorials are also active worksheets, so you can actually press enter on any one of those commands which is there, and it will execute that command for you. So in any case, let me just do both of them, but you don't need to do both of them. We'll just do one of them. For example, when I do a new document, this little quick help shows up, and you will get a specific space with a blinking cursor that is telling you you can start entering in here. And a lot of these commands are very simple commands. Let's do a calculation. For example, you can just type numbers. 4 parentheses -2 plus 6 close parentheses. Okay. Any one of these things, like it's 4 times. We don't use a asterisk for the multiplication. It's 4 times. And the regular stuff, if you want to do the power, you use the caret. If you use the caret, it takes you to the power, and you can say, like, for example, 3.2. And to come out, just press the arrow key to the right. Arrow key comes out of the power mode to the regular mode. And if you want to divide this by something, just use the front slash, and it puts them. It starts putting them in the um, bottom. And you can use the regular stuff that you will be using, like, for example, sine, cosine, log, whatever that you want to use. In here, I'm just going to have 5 to the power of 1.8. I come out of the power, and I come out of um, the the proportion, and press enter. And it will do the calculation, and it shows you the answer. Okay. Now this could be a long statement that you can do. So it just does those type of calculation for you, the ones that you do regularly on your calculator. Um, but let's start doing a little bit more stuff. So let's do expand, um, 3x plus 4 parentheses to the power. Caret is shift 6. Okay. And 5. And come out and press that. So I need another one back there. And press enter. So it is expanding this, it's multiplying that, and it's expanding that in a form that you want. Now you can actually factor out this. You can either type this, or you can just copy that. Okay. But if you are doing something, if you are doing specifically something that is related to the last command, you can always use a percent sign to refer to the last outcome that you have. For example, I can say factor. Um, I can either type this whole statement there, or I can copy and paste it there, or I can, because it is the last command in here, I can just say a percent sign, which means this last outcome. And if you do that, it will show you what it was made of. The other thing is that, like, for example, just uh, let me use another command, which is simplify. Simplify simplifies the things that you have. Okay. So I can simplify any statements, which is multiplication, division, whatever that you have in there. Um, Remember what it was is this. Let me just go ahead and copy this. So I'm just copying that. Simplify. Um, um, let's just put 5 over 4 and close parentheses. Okay. So instead of this, I'm going to put 3x plus 4. And for that one, I'm going to put this whole thing. Okay. So it simplified that to that was the power of 4. It is this one. Okay. And if you want to see what this actually is, you can just say factor parentheses 10 sign, which says factor this last statement and press enter, which will show you what you have. So you can, for example, evaluate this statement for any x that you want. You can say eval, and that's the evaluation command. You can say eval, and put any statement that you want, 3x squared plus 3x squared arrow plus 2x minus 3. That statement. You can evaluate that statement, and then you need to put a comma um, and say for what x. So you can say x equal 3 and press enter. And it evaluates that statement for that specific value. I'm just putting simple functions in here, but you can also see what that is. Um, Another thing that you can actually do, and this is on Maple um, 18 or something like that, is that you can actually go ahead um, and block one of those statements. And in here, it's actually going to show you the things that usually is done with this statement. Like, for example, you see that in here, the factor is highlighted, the 2D plot is highlighted. If you select the 2D plot, it actually plots the function for you. Um, and in this case, it is going to take its own measurements and so on, but you can actually specify what uh, what are specific areas that you want to plot. For example, for this, you can identify actually what the x, the range of x should be, what the range of y should be, all sorts of things you can identify. You can even identify um, the type of color and everything else that you see in here. And you can actually do that by just clicking in here and right clicking, because it is going to give you a lot of those options in here. And if you like, for example, if you change the color um, right here to red, you will see that the plot is converted into a red. Okay, so these are the very simple things that you can do, and it is very useful, um, that you can have. Now, same thing you can do in here, for example. Doesn't make any difference whatever the shape is, and so on. It actually tells you what you can actually accomplish with this. So this is a 2D plot of this function, okay, of this function. I can right click on it and choose a different uh, color, for example, for this. Maybe green. This will be green. Um, you can do that. The other thing is that when you do something like that, it actually puts the command in there for you. For that, to do any plotting, uh, Maple has a lot of libraries, just like your programming class that you saw in C++, that there are libraries that you can bring. There are a lot of libraries that usually don't load up, and you have to actually go ahead and load them up. One of those libraries is the plot library. Okay, and the way that you incorporate those is with the with command. So you can say with um, parentheses plot, um, close parentheses, and you can put a colon in here and press enter. Okay. If you don't do the colon and just put a semicolon in there, it is going to show you the things which are available in this library. Okay, if you um, ever want to do any one of those other stuff, everything is in here. Okay, for example, one of them is implicit plot. Implicit plot is just plotting the regular functions that you are providing for the uh, for anything in here. Now that this has been loaded, we are all the way in here, uh, at the bottom of this, and I'm going to do an implicit plot, for example. Implicit plot. I typed it correctly. Implicit plot. Yeah. Okay. And let's do an x squared caret 2 arrow plus y caret 2 arrow equals something. 4. You all recall from your previous life in calculus that this is a circle. That's a circle. Okay. Um, so you can do this, um, and just press enter, and it should give you a error which says, "Oh, there's stuff missing." And what is that stuff missing? Use it 2D argument, so x n, which is missing, and so on in implicit in implicit plots. So let's put those numbers in there. So in here, I'm going to say comma, and I want the x to go from -5 to 5. And the way that you are saying this is with a dot dot. So you say -5 dot dot 5. So what you are actually saying is that when you are plotting this, have the x go from -5 to 5. Um, and you can do that also um, with the y, comma, y from whatever, -6 to +6. So, so now if you press enter, it will plot the thing, and you notice that although you identified x from -5 to +5 and y from -6 to +6, they are not in here because your plot is restricted to these areas. Uh, you also notice that they are jagged because that's how it does the calculation. It finds point in here, this point, that point. It just plugs those points in there, and it will create that. You can actually do better in here since you see that this is what your plot is from, really, from -2 to +2. This is 4. So a square root of 2, a square root of 4 is 2. So this is x2 plus y2 equal 2 to a square, 2 to a square. So this is from 2 to 2, really. So you can actually modify these numbers the way that you want. Okay, so let's go and just add a number of points in there. Um, it's NUM points, number of points, and set it equal to a larger number. I don't know, 1,000. Okay, notice the plot that you have, and notice that it becomes better. Let's put 10,000. Notice that it becomes better. You are not doing any calculation, so don't worry about the load that it takes on that. 100,000 points. You see, pretty much now is like a round shape, um, and so on. So that's pretty much um, what you can do. You don't have to actually do a lot of uh, do a lot of um, fancy stuff. These things will give you the plot. And as I said, if you have a statement, you can just right click on that output and plot it right there, and it will plot right there for you. What implicit plot does is that it doesn't restrict you to a 2D plot. You can do 3D plots and stuff like that. For example, if we do the same thing that we have in here, let me just copy this. Paste it in here. But then this time I'm going to actually add a z also, plus z um, squared and equal um, maybe h. Okay, and I will go from pretty much same values. Let's change them a little bit because those are too big. Um, it doesn't make any difference. It just shows you what it is, and then you can go back and change it if you want. Y from minus 3 to plus 3. You don't have to do it like 3 and 3. You can do it 3 to 8, whatever. And we need to do one for the z as well. So z is going to go from minus 3 to plus 3. Okay. And with the number of points, that is going to be good. And press enter. Um, Error in implicit plot invalid input. The following extra unknowns were found in the input expression. The Z out. This is the 3D, implicit 3D. One of those things is an implicit 3D. Okay, so this is a implicit 3D. Okay, and press enter. And it shows you this. Let me reduce the number of the points, and you can see that this is like a spherical shape that you have in here. Um, if I reduce that a little bit more, you can actually see how the actual plot is. Let's change that a little bit. Let's put 3x squared, 3y squared, um, maybe plus 2z squared and 2z squared um, and 3y squared, and let's put a minus 4x squared in there. And let's see how it shows up. Okay. So this will be the actual plot that you see. Again, you can click on that, and you can do a lot of stuff with this um, as you wish. You can actually rotate this plot and see how it looks, and so on. So this is um, the the mathematical formulation of something like this. Now, if you increase the x's and y's, you actually see where the outside of that is. So let's do that from minus 6 to 6. And this one from minus, let's say, 7 to 6. I'm just changing them such that you know that they are not needed to be exactly the same numbers, from 5 to 10. Um, you notice those numbers are the numbers that you see on these axes in here. Um, so I'm going um, to use this and press enter, and it shows you a little bit more of that. You can always drag this any way that you want, um, enlarge it, zoom it, and so on, to see how the function looks like. So it looks like it is going up like that. But it is not exactly all over. These are very important when you want to find the maximum or minimum of the three-dimensional functions, and those are significant in operations research. So that's one of the things that we will be doing. Um, we are running out of time, so let me see if there is something else that is going to be um, useful to you. I showed you that these these functions that you had, you can just right click um, and and just go ahead and use that function any way that you want. Um, you can change the symbols. You can change the style. Okay, if you change the style, you can change the style to, for example, to point. And if you do that, it just shows you with the points in there. You can actually do this command inside this this function, whatever that you are using. You can actually show that um, as a function. So let me just do that before we uh, close. Um, okay, so let me do, like, for example, a simple plot. Okay, and I want to plot, let's say, a very simple thing, x squared, x caret 2, um, right arrow, and then comma, and then comma. You can just say symbol equal circle. Okay. So when it plots this, symbol equal circle, style, I have to identify this style. Style, style equal point, and the symbol for those points to be circle. If you do that, you can actually get that through the commands um, inside the plot function. You can make them solid, dash, whatever it is. Oh, all sorts of stuff that you can do that. Not only that, you can actually plot different functions on the same plot using the same command of the plot. So let me do this as the last thing. Um, you can just say plot parentheses, and then in here identify more than one function. So you can in here use a bracket, like for example use x, similar thing that we did, x caret 2, right, and then say comma. You're now identifying two different functions, and this one, like 2x plus 1, or just 2x. Okay, close the bracket. Now you're saying plot two functions. One is the x squared, the other one is 2x. Um, Um, Again, you can identify the values of x that you want. I'm just going to um, just cut that part out. You put a comma in there because you have two functions. Whatever you do, you have to assign it like a two different things. Okay, let's say that I want to have a color assigned to this plot. Color um, assigned to this plot. Again, I have to use the bracket, And in here, for example, I can say black, comma, blue, close bracket. Now it's what you're saying is assign black to x squared, blue to 2x. Um, you can actually make them different shapes and format. Again, with the right click on the plot, it is easier to do. But if you want, all these commands are also in here. Line style. Line style equal a bracket. You can say solid, comma, dash. Close bracket and close this, which says plot x squared, black, solid line. Plot 2x, blue, and dash. So hopefully if I hit them correctly, you will get the 2 in there as well. Again, you can click on this and right click, and it does all those stuff for you. The other thing, the only difference that is between, and uh, this I also need to mention. Remember that when we started, I said new document. You can say new worksheet. Okay, and if you say new worksheet, the only difference that you see is this. New worksheets are usually for the math stuff. So any one of those commands work in here too. But they are all commands. It requires all commands. In when you are in the document mode, um, if you want to, for example, if you want to type something, you said, my name is, okay, that's it. That can be done. It doesn't make any difference. You can type anything that you want, but when you are in here, it's expecting that all these commands be the maple command. So if you need to enter specifically a text, you need to actually click on text, which will take you to a document mode that you can just say, my name is. Why is it good? If you're turning in a homework at the top, you do this and then you put the commands and everything is going to be there. Now, again, if you press enter, you notice that nothing is going to show up in here on the right hand side because it's assuming that this is a text. Now you are in the text, and if you want to go back to uh, to this mode, you just press tab level. Okay, I hope that you got some basic information about this.